we're here in the West, and all medicine is biological medicine. And then we have a book like this from Jerry Tennant. Excellent book. I've read it a couple times. You can see I've taken a lot of notes on it, and I reread it to write this chapter. But I've looked at a lot of other videos and content on energy medicine, and I think they're all kind of missing the foundation of what energy medicine is. And we always have to go back to peel the onion back to see where it comes from. Okay, what is the ultimate source of energy, and how can we use that in our physiology? So I put up, I believe, on our blog a link to Roger Schwelt's MedCram, sunlight energy. You can look it up, MedCram, sunlight energy, and you'll find that video. And it's a little bit long, a little bit redundant, but he brilliantly done. And he dissects the work of a researcher by the name of Zimmerman, I think, that really explains whence sunlight energy really has a major impact, how it has a major impact on our health every day. And so many of us are not getting sunlight. And, I think about a guy like Mercola, besmirched in every way possible. And, he has a pretty big team, and he has to produce a lot of content every day. And the one thing I wish he would do would be to prioritize, when he puts out a new piece of content, where does this fit on the 0 to 10 scale in terms of relevance and importance? But looking at his own life, exposure to sunlight is extremely important to him. He goes out half naked every day and gets bright sunshine. He's down on the Florida East Coast, and that's a very important part of his daily activity. He doesn't take a vitamin D supplement, nor do I. His vitamin D is 70, 80. Mine, last time I measured it, was 65, just from getting sunlight. So, that's one way to answer the question: am I getting enough sunlight? Well, if your vitamin D is below 55, you're not, period. If your vitamin D is only above 55 because you supplement with 5,000 IU a day, then you're only getting a portion of the value of what the sun can bring to your health. So get out there and get more sun. That's the best advice I can give you. And I doubt, knowing how I bloviate, that I won't get to this solution today, but we'll do part 2 in another time on energy medicine, some of the solutions I have for you. And many of them, we've had the lectures, Marvin Berman, photobiomodulation and neurofeedback for the brain. Andrew Rosenfarb, electroacupuncture, providing electrons and energy across the eye to heal eye pathologies. And I was listening to, it's hard to remember which lecture I listened to. It was either on the Brave series, or I think it was the Brave series. And I put that up on my blog as well, a short snippet from that. And at the end of the day, I think it was Tom Levy who said, at the end of the day, disease is oxidation, which means the loss of an electron. That's what oxidation is. And healing is reduction, a gain of electron. And that's it. Now, there's some caveats to that, because our immune system works on oxidation, but it does it very specifically. It oxidizes pathogens, not you. So that's really important. So it's oxidizing the pathogen to kill it. But if you are in an oxidizing environment of your own, then you're basically killing yourself. So we need to get into a reducing environment. How do we do that? We need electrons. So these AC alternating currents, microcurrent, all these things provide electrons to you. Fish oil. People don't like fish oil because it goes rancid. Okay? Why does it go rancid? It oxidizes. In the process of oxidizing, what does it do? It gives up an electron. And if you're eating fish oils, guess who's getting those electrons? You are. That's why it's anti-inflammatory. Okay. Iodine, you know, can either take electrons from a antiseptic perspective or give electrons. And our body can cycle it from the oxidized to the reduced state. So just for a little terminology's sake, there is, you know, we talk about oxidation and we talk about antioxidants. Antioxidants is just what in chemistry we call a reducing agent. It gives an electron. Okay, so that's a very important concept. And we can have too much of a good thing. So what you're going to hopefully learn from me, but I learned from others, and some of this is relatively breaking news in the last 5 or 6 years, that we've got to differentiate between when oxidation is working for us, immunity, versus against us. And you know, Mark Hyman wrote a book many moons ago, and he talked about a few different mechanisms. One of the things he talked about as a major mechanism is rust. And what he really meant, and he knows it well, is oxidation. So we do have to be careful. So, you know, you're not going to take antioxidants willy-nilly. It has to be done, you know, in the right way to marry to what our physiology is doing to affect the use of these substances. And then Dr. Stark says, but wouldn't it still be the dose of how many electrons are gained? That would be healing, i.e. hormesis, although I guess you were right. You know, so the beautiful thing, Dr. Stark, is we don't have to take things at the exact ratio that our body may use them, but we need to have the Home Depot shelves stocked up well so that our body can figure it out. You know, one of the most important things in our body is active transport. That is bringing things into and out of cells. And a third of our energy goes to just that simple process. But sodium and potassium regulate that. But I don't have to take in sodium and potassium at the exact ratio by which active transport uses sodium and potassium to affect that process. So as long as I have a reservoir of it, then you're all set. One thing is, what is it? Bob Sheeran, Dr. Carter, we met with him at in Marietta, and he wrote the Mayo Clinic newsletter for 14 years. And, you know, there's a big concern about potassium. He says if your kidneys are functioning well, you know, your body can manage potassium. If it has more than it needs, it'll excrete it. Now, I'm not saying go out there and take huge amount of potassium pills. There's a big concern about potassium stopping your heart. Dr. Carter can explain that mechanism, but you know, it's all electrical at the end of the day. But that just shows you how potent a electrical facilitator something like potassium is. And the RDA for potassium is higher than the RDA for sodium. And I would argue that a lot of people with high blood pressure have a potassium deficiency. I wrote a white paper on that based on research at Harvard. So it's not a sodium excess, it's a potassium deficiency. But once again, don't go taking potassium unless you do some testing or are guided by a physician. And that's why, even though the RDA is in milligrams, 4,000, roughly 4,700, the only potassium supplements you can get are 99 milligrams, you know, a fraction of what the RDA is. Whereas most other supplements, you can get them at the RDA without any issue. But this one's like 50 times lower than the RDA. So there's a worry about potassium. But anyway, lost your sound, Dr. Hartsfield. I hope you can land the plane when I'm done. But so I'm going to slowly work my way through energy medicine, and yes, it'll be a little technical at times, but I think it's really important that that we understand whence it comes, and then hopefully we'll talk about how to get it. And we have a number of energy medicine providers in our network. But you know, if you want to understand how, I'm gonna kind of read this. Hopefully it's not, because I didn't really prepare a talk, but hopefully I wrote it in a way that's readable, not too intense. But if you want to understand health, energy is fundamental. The number one complaint I get on our risk survey, the chronic disease assessment, is low energy, lack of energy. Pain is number two. Dr. Harshfield, we can't hear you. I hate to say, I'm sorry to say, but you know, we've had this conversation many, many times. In my opinion, pain is an energy crisis. So if your number one complaint is lack of energy, number two complaint is pain, that's really lack of energy, specific lack of energy. So 1 and 2 are energy. Okay. So now hopefully in that context, talking about energy medicine has a whole new perspective in terms of what you want to do to heal. So our bodies are biologically pure, but biology is there to drive electricity. So the reason why I brought Dr. Tennant's book up, Healing His Voltage, is when you look at his book, and I'm not going to publish one this long, but compared to what I wrote, this is a short book. It's only 500 and 600 pages. 80% of it's talking about physiology. 80% of it's talking about digestion, nutrition, all those kinds of things, because, you know, we're normally not going to put electricity into our body. Judy will tell us that we need to get rid of static electricity, because that can impede the flow of good electricity through grounding. Really important point. But we're not, most of us aren't plugging ourselves in at nighttime. So we rely on our physiology to do the work. But when we can't fix that physiology through supplements, nutrition, exercise, whatsoever, then actually, applying energy is important. With one caveat. With one caveat. Does anybody know what that caveat is? No one's raising their hand. Anybody in the chat? What is the one caveat about not doing daily treatment with energy medicine? Let's see what we have. Wayne always has some obtuse things. I love you, Wayne. You know, so don't worry about it. Shortfall electron donors, or body needs time and space for repair. That's not it, but you know, obviously that's why we sleep. Shortfall of electron donors, no. Go out, hormesis, yes, but not close enough to the source. Go out and get some sun. That's the energy that we should be getting every single day. Every single day. I'll step ahead a little bit before I continue to go down this route. But what Roger Schwelt did in his evaluation of our evolutionary behaviors, that even in the 1800s, 50% of the time we were outside. I mean, we weren't all covered up. And then you can see an asymptotic decline in sunlight exposure that we get. And now, according to the latest statistics in the United States, we are outside 7% of the time, often with sunscreens or covered up. I'm taking this trip to Europe and I'm looking for these very lightweight pants that you can zip the knee off, and so you can be double as a short and long pants. And they're all advertising how they have SPF 50 incorporated in the fabric. And I'm saying, I don't want that. This is North Face, Columbia, all this stuff. It's like, we evolved under that sun. I want it all. I want it all. I don't want to be gypped of any portion of the spectrum, not one single portion, including the UV. I don't care if I'm a little wrinkly. I'd rather be healthy and wrinkly than the converse. And I'll show you really good statistics on that. Probably the way I'm going today, probably on Bastille Day, which is July 14th. Just a joke. but meaning it's going to take me a while to get there. So the only real useful ongoing source of energy on our small planet is the sun. In this chapter, I show how energy on Earth is delivered and how we have adapted in harmony with this energy to be healthy. However, most of us in the West are unaware of the value of energy medicine. Looks like I'm searching energy medicine here. We'll get rid of that. Energy medicine, what it does and how it works in harmony with our biology. So we think about, once again, we think about, where do I go to find an energy medicine practitioner? It's like, step out your front door. I don't know who this dude is, but I know that Brian Balin quoted the same guy. In every culture and in every medical tradition before ours, healing was accomplished by moving energy. We don't do that. We move drugs. We're a bunch of drug pushers now. What's the best way to obtain energy medicine? Okay, this is the crux. Well, you want some proven method that's safe and effective and inexpensive, right? You also want to work with a practitioner who is competent and experienced. The solution that meets all these criteria is to go outside and get plenty of sunshine. Your practitioner is God. Okay. So I laugh or cry at the concept of renewable energy. Why? Because all energy on Earth is renewable as it comes from the same source, but just over a variable time window. Okay. In other words, eons ago, the plants that led to coal, oil, natural gas all came from the sun. That fundamental energy is fusion. So there's what's the name of the Tulane University one time had a tagline, Harvard, the Tulane of the South. And then when I was looking up sources of energy, Tulane had 5 listed, and 3 out of the 5 were secondary to sun energy. So they really didn't get it right. Fusion is the process that powers the sun and the stars. It's a reaction in which 2 atoms of hydrogen combine together or fuse to form an atom of helium. The energy produced by nuclear fusion is conveyed from the sun, from the heart of the sun, by light waves and heat. The light waves are called photons, but the Earth is separated from the sun by 93 million miles of vacuum. Okay. And so therefore, even though fusion creates a whole lot of heat, we experience none of it on this planet.
I could just figure out how to permanently change my name.
Don't change your name, Lynn. You're fine the way you are. Mom, my daughter changed her name because she said it haunted her entire life. But she's happy with her new name now. It's fine. She's still my daughter.
Sorry about that.
No, that's fine, Lynn. We love you. We love you. We love it all. We're a convivial group. Anybody who wants to interrupt me and say, Dr. Lewis, you're droning on and ain't making any sense. And let's cover like COVID today. But so the energy produced by nuclear fusion is conveyed to the Earth, to the heart of the sun by heat waves. The Earth is separated from the sun by 93 million miles of vacuum. A vacuum is a perfect insulator. And proof is my Yeti coffee cup, which at 10 a.m. is still scorching hot when I made my coffee at 6 a.m. It's because it's a vacuum. Okay, just the top is not a vacuum. Oops, I did something funky with my screen here. Oops, hold on one sec. So however, photons contain no mass and do cross the Great Divide. We know this because we see visible light photons and feel the infrared photons as heat. So what I tell you to do is do a little experiment. Get a halogen lamp or an incandescent lamp, sauna space that Mercola talked about, I think is the right sauna because he uses incandescent bulbs. He's not using LEDs with specific frequencies. So he's using incandescent bulbs, which look very similar in profile to sunlight. That's what we evolved around. I think halogen light better. And put your hand quickly through the air or get a thermometer and put it in the air in front of the halogen lamp. You'll find that the air is not very hot or not that much hotter. So that's conduction. But what you really feel on your skin is the interaction of the red light or infrared light on molecules, chromophores on the skin, and that's why you feel heat. No different than fusion from the sun. There's no heat going across there, but we feel it. We're feeling it because we're absorbing the red and near infrared light by the interaction of what are called chromo light pores on our skin that then get converted to heat. And we'll go into that whole process. Wow, this chapter is like 50 pages, and I'm on page 1.5 hours. So there you go. So there is just one main source or energy on our planet. It's derived from the fusion reaction. The equation for that energy is E equals mc squared. Steve, you can be my fact checker, okay? But I want to explain what temperature is. You know, we learned this in chemistry. I know you all had chemistry in 11th grade or maybe 10th grade, depending on your age. But so I have in the footnote here, heat. Why is it 11? Okay, I know why. Heat or temperature is a measure of the average movement of substances or particles referred to as their kinetic energy. So when your skin warms up, there's motion increasing in your skin. Okay, and it can be radiant, like I'm heating up oxygen and nitrogen and carbon dioxide and argon, and that's coming and interacting with my skin and exchanging some of that energy. Just like if I had Dr. Carter and I gave him a little push and he gave me a little push, we're exchanging a little energy. But that's not really what's happened. It's really much more quantum. It's the interaction directly on that molecule, causing that molecule to have excess motion. Okay, we'll get into exactly what that is. So in order for heat to be transferred and move from one place to another, there must be particles present. In a vacuum, for example, between the Earth and the sun, there is no way to deliver heat through the normal classical means. That is, by the exchange of energy between particles. You know, I push this one and this one pushes that one and so on and so forth. That's not happening. Because remember, light is massless. Okay. That is by the exchange of energy. Okay, so I don't go into it. So anyway, so all energy, with a slight caveat, comes from the sun, daily and historically. The only caveat to that is gravity and radioactive decay and the rotation of the Earth contribute about 0.03% of the total energy on Earth. The sun contributes the rest. So extremely important to go out and get some sunshine. So Earth does not make very much energy on its own, but does get the sun's energy through the light that hits our small planet. The equation that defines the energy is E equals H, which is a constant. So you can take that out. Nu, which is the frequency. So energy and frequency are intimately tied together. And of course, there is intensity, because, you know, the more intensity we have, the more energy we get. But if that energy is, if it's a low frequency, like radio waves, you can have all the intensity you want, and all you do is hear more noise. But in the UV, that can be a problem. In the visible, it can be a problem. Certainly in the X-ray and gamma, which are very highly energetic, the dose certainly makes the poison. Dose makes the poison in all cases. But the only way our planet gains energy is by converting light into a workable form of energy. And it's mainly by way of plant photosynthesis. But guess what? Humans also perform photosynthesis. Very much so. Even if it's just the movement of electrons, not the joining of atoms together to create new molecules. So for example, photosynthesis, we're taking carbon dioxide in the air and converting it into complex carbohydrate structures, which are just carbon atoms with oxygen strung together. That's all it is. But plants are not the only organisms that absorb energy from the sun, so do you. It happens on your skin, your eyes. Oh, I gave it away. Your ears and a myriad of other photoreceptors and chromophores. So photoreceptors and chromophores are specific terminologies for substances that do important things biologically in our body. But there's not a single molecule on God's green, white, black, yellow, transparent, visible, that does not absorb light. Every single molecule absorbs light. So in that respect, every single thing is a chromophore or a photoreceptor. But these are broken down into a little bit more specificity in terms of ones that do actual very specific work within our physiology. But you know, if your skin absorbs a little light and you feel warmth, that's not just a chromophore or a photoreceptor. That's essentially every substance in your skin is absorbing some of that light. The terms, so I say the terms photoreceptors and chromophore are a bit, I haven't copy edited this one yet, bit of a naive concept. Is essentially all substances interact with light of varied or specific wavelengths. Now, if something has a color, it absorbs visible light. We know that. But that's not the only light it can absorb. It can absorb UV, it can absorb infrared, it can maybe absorb microwaves, absolutely. So that's why we worry about 5G, because almost every substance that we're composed of can absorb microwaves. And so what do microwaves do? I'll hold that one back, but it does something. And you all know what it does if you have a microwave oven. It heats things up. Infrared heats things up more efficiently than microwaves, but microwaves heat things up with a slightly different mechanism. So we want to make sure we're not getting too many microwaves, because we don't want to be simulating our home environment to be the same as a microwave. Not a good thing. So for simplicity, the terms photoreceptors and chromophores are adequate to describe the components of biology most associated with the absorption of sun's energy. Thus, both plants and us have photoreceptors that can interact and absorb with energy from light. The word photo is short for photon. You know, that's what E equals H nu. You know, it's a photon. We measure the energy E in terms of photons. Many of us, I know not this group, assume that the light is only what we see, that is the visible light. You see the oxygen you breathe that drives your metabolism. And the answer is we don't. I always tell people when they say your dog belongs on a leash, and I go, she is. And they go, no, she isn't. I said, well, can you see the oxygen you're breathing that's keeping you alive? No. No, you just can't see my leash. She's on it, trust me. But anyway, that was obtuse. But anyway, so of course not. Much of the energy from the sun comes in light packets that we do not see. Infrared light carries more than half of the energy that reaches Earth. Yet it's lower energy than visible. So we're getting a lot more infrared light on our planet. And guess what? We adapted to receive that light and do something valuable with it in our bodies. Okay, so here's the sort of the chart. Figure one below shows a wide range of light. So we have gamma rays. Those will just blast through anything. Hopefully, because inside your body, 99% of the space is unoccupied. Hopefully it passes right through, doesn't hit a nucleus and blow it up. And if it does, hopefully you repair that nucleus. X-rays, same. Ultraviolet light creates highly reactive electrons. Visible light produces very nice little available electrons for us to use, if we can get them in time. Infrared, what infrared does is causes bonds to pivot and vibrate, doesn't break them. Ultraviolet can break, X-ray break, visible maybe break, but most likely not, just make an electron available. And then microwaves causes bonds within a molecule to rotate. And since temperature is just a measure of the movement of substances, if a microwave increases temperature, if an infrared light, near infrared, far infrared, increases temperature, really all it's done is increase motion, vibrational motion, rotational motion, literally creating friction, if we want to look at it from a classical perspective. So that's all that's really going on with the light. And then radio waves, when you look at photoreceptors in our body, we can actually see some of them, with the right imagery. So like in the back of the eye is a retinal nerve fiber layer. It is measured in microns, and that's the full layer, but the layer is broken into many little teeny segments. Okay, and those little teeny segments get down to a molecular level where it can absorb the light of a frequency of a certain size. And a frequency is certainly just how many times that wave passes a fixed space. So a radio wave is very big, whereas a ultraviolet light is very short wavelength. And the shorter the wavelength, the more energy it packs. Okay, so the smaller it is, the smaller the tissue has to be for it to interact with. And so the retina is measured on a submicron level on its component parts. But the other photoreceptor you have is your ear. And that's a very large detector, if you will. And so you're detecting, large sound waves that interact with the size of your ear. And your ear, of course, evolved around light of that particular radio wave size. Is that clear as mud? The range of photons. I'm going to cover one more concept, which I'll have to skip down to, that's really important for the next time. But the range of photon light waves that come from the sun. Okay, the light contains a range of photons with various frequencies. And once again, frequency is energy. Okay. It is the frequency of the light that determines the energy it contains. A single gamma ray has 10 quadrillion times more energy compared to a single radio wave. Okay, and that's 3, 6, 9, 12, 15, 16, 17 orders of magnitude more energetic, but it's all the same thing. It's just a wave of light. But that's how profound the differences in the energy. I think that was really interesting to see. I'll come back to this NASA thing, but the way you can interact, radio waves, AM radio, PET scans, airport scanners, those are using X-rays. And then we have visible light that we can see, night vision goggles to see the infrared light, or using your TV remote. You can't see that beam of light, but it's interacting with some kind of a photoreceptor on a detector on the other end that causes an electrical signal or switch, things like that. But we're going to skip down a little bit, and I want to introduce a very important concept that may not change the way you manage your health, but it's just an important concept so you understand how this goes on. Knowledge, what Dr. McCullough said in his most recent, not the most recent, within the last 2 weeks, his 5 tips on health. And the 5th tip he gave is never stop learning. And what I'm trying to do, because Dr. Carter and I talk about 5 mechanisms, is give you sort of a foundation upon which to craft your arguments. If you understand things at the most fundamental level, then all of a sudden everything becomes clearer. Okay, and hopefully that's your ultimate goal, because we have to, knowledge is power, and we have to have that knowledge to combat things when they say, like, take a statin drug or stay out of the sun. Michael Hollick, who's on every LabCorp report for vitamin D, was thrown out of the Dermatology Society 25 years ago for the blasphemy of saying go out in the sun. and we have to start being able to explain why sun is valuable, why melanoma is not a sun cancer. Okay, it's a cancer of the skin. I'll go into that data as well. But every reaction, except to what's going on in the sun, needs a push. If I take the two most reactive substances I can think of that we can easily do an experiment with in our head would be hydrogen, or we can pick gasoline, similar, and oxygen. And I mix them, and what happens? Other than nothing. Nothing. Okay, why? Because when they react, they produce gobs of heat. So the products are much more stable than the reactants. And that would be called an exothermic reaction. So here's the energy of the reactants, gasoline and oxygen. But the products, carbon dioxide and water, are much more stable. So there's a big release of heat when that happens. Could be light as well. Doesn't have to just be heat. But there's an activation barrier to everything. Okay, there's an activation barrier. Otherwise, I'd mix gasoline and oxygen, and they just blow up. We couldn't live in a world like that because we couldn't contain these things properly. But instead, we put it in the gas tank, pouring it in. There's air all over the place. 20.9% oxygen, no problem. We just don't want to match or something like that. So activation barriers are a really important concept in health and disease. And I'll be going into that in hopefully laborious detail. But the beautiful thing in our physiology is, guess what? We take in calories. Why? To make things happen. We need calories, just like your car needs calories, gasoline to move. Moving your car takes energy. Okay, that's called an endothermic reaction. We have to put energy in to get a product. The product of movement is takes energy, whereas the product of combustion releases energy. So we have to have a releasing reaction called an exothermic reaction in order to drive a taking reaction, moving your vehicle. But in all cases, whether the reaction takes energy, walking uphill with a bucket of water, or releases energy, taking that water and pouring it on a water wheel and connecting that to a turbine and lighting up a light bulb, there's always an activation barrier. Okay, and I think understanding this is Dr. Carter and my first mechanism of disease: poor repair and recovery. Poor repair and recovery due to poor nutritional choices or poor absorption, or in our current world, every good attempt to get good nutrients, but our food supply is just garbage. But that has everything to do with these little curves here. And it has everything to do with how sunlight plays a critical role, okay? And hopefully I'll put enough science behind getting out to the sun that, you go, like, I think it was just yesterday. It's like I live in a little neighborhood, it's a 1 mile loop. And, there's a bunch of older people, and I guess I'm an older person too, whatever. And everybody's all dressed up. They get their hoodies on, and it's 78 degrees out. And I said, why am I letting society dictate what I do when I know what I'm doing is right? So I stripped down to just, a small pair of shorts, and I went out on a mountain bike ride around my neighborhood and then up into the woods and stuff like that. Shirtless, and McCullough does it all the time. He says he does that. Why aren't we all doing that, And hopefully when I explain how sunlight dramatically changes the height of this activation barrier, and if this activation barrier is high enough, the reaction that's very important in your physiology for healing may not happen, or may only happen to a small, inadequate extent to keep ahead of your wear and tear. Okay. So with that, I'll just go over this one more time. In your body, there are reactions that require energy all the time. Okay, that's why you eat food, carbs, fats, proteins, and burn them to produce energy so that you can do things like sending your car, the equivalent of sending your car down the road physiologically. And the most important thing that we know of that takes a lot of energy is moving things in and out of cells. Active transport takes a ton of energy. You have to be able to push that up and over an activation barrier and to a higher energy level that required. It's like carrying water uphill. And then we have other reactions that flow downhill. That is, we get more energy from them. That, you know, we get energy out of them. However, in all cases, there's this activation barrier that if we don't overcome that, it ain't going to happen anyway. And with that, I will call it quits for the day and see what we have for questions. Dr. Carter, what did you think of that introduction on energy medicine?
Quite extensive.
No, see,
and a dip.
The reason why I'm doing this is because if we're going to bring energy medicine to a bigger, to a more relevant place in America, we have to understand its value and what it's doing at the most foundational mechanistic level.
Absolutely.
Otherwise, it's just hocus pocus. It's another, you know, I had someone yesterday, oh no, it was today, a doctor that I'm working with, say, you know, voodoo medicine. And he didn't mean it in a negative way. He was just saying it sort of as an example of what's wrong in the system. So like if in the West, we're going to turn energy medicine into a real thing, it can't be perceived as voodoo.
Right.
You know, and if we can show how it works and get people to understand how it works, you know, my first business partner worked at Procter & Gamble, and he said, you know, how Procter & Gamble became successful with what's called pull-through marketing. In other words, they would advertise to people, and then people would go to the store asking for that product that wasn't there. And if enough of them went there, then suddenly it showed up on their shelves. You know, and we got to create pull-through marketing for energy medicine. So we got the coupon for Dr. Patel. Any of you brilliant people, Andrew, come on, you must have a question about what I talked about today.
I'm working and I'm driving, but I'm listening. Going in. Yeah, I think you're smack on. It's brilliant what you've done with that book, and I know how much work goes into that. But yeah, this whole idea, even really, you mentioned the vacuum. I think there's a pretty good debate around whether that's ether or whether that's a vacuum. But we'll come back to that.
Yeah, well, I'd have to know what, you know, in terms of forms of matter, I'd have to know what ether is. You know, I mean, there's liquid, solid, and gas, and then there's plasma, you know, from fire. But it's like, there's got to be something that, if I can measure it, I mean, maybe I can't measure everything. I mean, in quantum mechanics, you can't measure everything. But, you know, good point. Andrew, I played hockey the last 2 weeks. I'm going to keep playing it. So one of these days we'll meet. Could we get someone who is an expert in B1 deficiency? I'm sure Dr. Carter is that person. Does anyone have a code for glutathione? Thank you. Is it possible to discuss the movie The Real Anthony Fauci? Watch it. That's all I can tell you.
Oh yeah, they did a really good job. Jeff Hayes did a really good job with that. And then of course, then they had a great question and answer with Robert Kennedy, Robert Malone, and Pia Corey. You guys should definitely watch that. But yeah, we're gonna have them on, right? When is
I'm working on it, Michael. I need you to write a letter. I need you to write a note to Corey, because you know he has a better relationship with you. But we're getting them.
Yeah.
Doris says my vitamin D is 84, taking 10,000 IU. That's good. It's actually higher than I anticipate, so you must be getting a little bit of sun. But I suggest you move out of Jersey and go to Ecuador, go to Ecuador for a while.
Pay my way and I'll go.
There you go.
I'll buy you a bike, Doris. You can ride down there. I'd like
Is
to
this gonna
explore.
bother you? Can you hear this?
Go ahead, Denny.
Okay. Let me know if it bothers you.
It won't bother me.
Okay.
Denny, are you asking a question?
I got sixth graders, you know what?
So I'd like to explore some of the key reasons why some people have subpar absorption of vitamin D. You know, there are many nutrients, but just because your vitamin D is low doesn't mean you have low absorption. It means you might be converting it to the diol and triol. So those should be measured before you, but I mean, always can fix the gut. Here's dark to start. I already answered that question. I use whatever that is, a wand to structure my water every day and help heal my cells. You know, Roger Schwelt and others have said, leave your water out in sunshine and it'll structure it. Potassium supplements are much stronger per milligram than potassium in foods. I don't know about that. I mean, 99 milligrams is pretty light. So, but I always say, you know, look up foods highest in potassium, and, you know, avocados are very high. We have a chart on one of our videos on nutrition that gives a lot of different statistics. I'm not sure potassium might be one of those. Let's see.
It's really high in, you know, the vegetables, of course, and it's wheatgrass has a very robust amount of potassium as well, and in banana peels, well, bananas as well. But yeah, that's there's a product out. I'm blanking on the name of it, but yeah, everybody's pretty much deficient in intracellular levels of potassium. So,
Michael, a gazillion years ago, I started taking alfalfa, and I haven't done it in a long time because alfalfa has very deep roots. Any comment on alfalfa as a nutrient?
I would think it would, yeah, absolutely, like the alfalfa sprouts and so forth. You know, that, and like the big thing now, of course, is broccoli sprouts that you can make yourself. There's a book on sprouting that's actually pretty good, because that's the, you know, the highest source of nutrients that you can get when you can actually sprout some of these things yourself.
Right. Patricia says she uses a D-Minder app to tell when to go outside and get the most vitamin D. So here's something that I'll talk about in upcoming on this, from this energy medicine chapter. But what was shown by Zimmerman is that if you go out and get sun early, that you kind of, we don't know exactly what it is, but you might be stimulating certain pigmentation cells to protect you from UV. So what Roger Schwelt is saying from the research from the Zimmerman paper is that if you go out at high noon, there's a good chance you might burn. But if you go out at 8 a.m. and you're still out at high noon, there's less of a chance you'll burn, because your body gets sort of like pre-treated for the UV at the top of the hour. So as good as these apps are, the only real solution, which I know is rather impractical for most of us, is to get outside 50% of the day. You know, I'm outside a lot playing tennis and pickleball. I've noticed the past couple of years, the intensity of the sun is painful, even in the car. I'm wondering if ozone depletion. Interesting. Well, I wonder what your latitude is, but you know, that's
I'm in SoCal.
SoCal. You know, what Ron Neer says is that you know, so get out earlier. I don't know if that's it, but that's a part of it. But then sulfur tends to be protective. I'm sure there are other things that we may be deficient in that may be may be protective that we're losing as we age, or it could be the ozone, could be intensity. I haven't really looked into that. Needs to be a level 3 for the sunlight vitamin D to be effective. I don't even know what those are, Steve. Maybe you can tell us next time. And then there are 24 other messages. Laura, what are you saying? To protect yourself at home and work from 5G and microwaves. Somavetic. Yep, we had them on. I think that makes a lot of sense. But love my Somavetic. And Raquel says, hi, Laura, I'm sure you see that. But anyway, we don't have, we're right at 1. So, Dr. Harshfield, are you truly off the grid today, or are you going to land this thing for us? Looks like he's off the grid. So in that case, so how I induce you to stay and continue to listen to these energy medicine chats, really what they are, like Pierre Corey is doing his fireside chats now on COVID and post-COVID syndrome. But I am going to show you a $100 sauna sunlight simulator at the end of all these discussions. So is it as good as going outside? Is it as good as a sauna? You be the judge, but I'm doing it every day now. And I've increased my consistency because I measure my athletic performance very accurately. And that in my opinion is sort of the best metric, because that's high stress. Okay, and increasing sunlight and surrogate sunlight and iodine has made a profound impact on my consistency. I haven't changed many other things. So, and with that, I will see if I can answer some of these next time.
Jack's hand is up.
I'll be publishing this chapter as I go along, and I'll try to put the questions. I promised that before, but since this is my talk, not someone else's, I'm more equipped to answer them. We have a hand up before we go. Jack, go ahead.
Yes, so I've been familiar with microcurrent electric therapy since the mid-'80s, and more recent years, pulse electromagnetic frequency field. How would either of those be relevant to your current discussion? Would MET, for example, in your opinion, provide more of the energy that you're referring to? And how might PEMF be different and more appropriate for certain healing?
Yeah, that's a great question. Any kind of microcurrent therapy is going to be providing electrons. And so, we may have, like, if you have pain in a joint, or you're, a scar tissue, or you're trying to heal, there's no question that that putting a current across that provides electrons and enhances healing. Now with the PEMF, I'm not an expert on this, but what I understand, I do understand electromagnetic, light is not just electro, it's magnetic as well. And the magnetic field is dramatically less intense compared to the electric field. So the electrons play a more important role, but I believe the PEMF has an interaction with our magnetic field that probably helps in the same way. How it interacts and how it changes physiology. Increasing blood flow is what everybody says it does, but I haven't really delved deep into the magnetic component of that.
We're gonna have a talk about Dr. Pollack. He's like the guru of PEMF. And
exactly, yes.
Yep. So he'll be coming on.
Good.
Excellent.
That's great.
Jack, thanks for raising your hand and asking the question. And with that, folks, if you want a higher dose of the same thing tomorrow night, I'll be discussing it similarly, and then we'll move on to page 3. Thanks very much. You're welcome.
Thanks
Bye for
much.
now.
Thank you.
Bye now.